Okay, so just wanted to start the broadcast.
Good.
So I think we've talked about you know, a little bit how it's overwhelming and everything to us. So again, James, I'm really happy you're here. You seem to get it a little bit better than us, and so I'm glad you were able to be with us.
I'm glad my plans canceled on us.
Yeah, well, my prayers were answered then, so that's a good thing.
Should we dive into the quiz?
Yeah.
Yep.
And then when we crash and burn, Sister Lemon will bail us out.
Yeah. There you go.
I have a feeling this quiz is not going to go as quickly as last. As the quiz.
No, it was last week's.
No.
Okay. Question 1, true.
Yeah. Wow.
Question 2, true. Okay. Question 3. We'll need the normal probability applet. So shoot.
Well, this is just a question though. The total area under a normal distribution curve must equal.
Oh, what?
1, right?
Yep.
Yes.
We're all good with that? Okay.
Yeah.
So, and it's under certain circumstances, a normal distribution curve can drop below the x-axis. X is the horizontal axis.
That would be false, right?
Yeah.
That's false.
False.
Correct, it's false.
A normal distribution curve is symmetric. That is true.
True. It's bell-shaped or symmetric, yeah.
Oh, bell-shaped. Yeah. So it's true.
Yep.
Oh, sorry. My video paused. For question 4, was that
that's
that
false.
One, that was false. Okay.
Yep.
Yeah, that's false. The x-axis is the horizontal axis, so it can never go below the horizontal axis.
And then the y is the vertical.
And y is vertical. Yeah, so that's what gets me too. Is like they call it one thing in the book, and then they call it something. And I know we know what x and y are, but still, it gets, you know, every little thing kind of sends me over the edge. So use the following image to answer the next 2 questions. All right. Which of the following elements of the figure represents the z-score? So the z-score here is C.
Yep.
I concur.
Yeah.
And then following elements of the figure represents the probability that the z-score will be greater than 1.00. So which one?
Be closer to
that's B because it's
That'd be B.
Right, because it's not the negative.
Okay.
Yep.
According to the 68, 95, 99.7 rule, what percentage of the data from the bell-shaped distribution will be within 1 standard deviation of the mean?
68.
Right.
0.68.
I think you're supposed to write it as 6.8.
Yeah.
Don't answer it as a percentage.
There it is. Yeah. Okay, got it. Don't write it.
Which is really unusual.
Yeah.
Most of the time we're always answering in decimal form, not in percentage.
Right. So it's just, you know, and that just reinforces how you really have to read each question start to finish, right? Like you can't just, oh, look at it. Because I did that with as we said on the one test when I got it right the first time I took it. And then I took it the second time and I got that question wrong because I didn't read it. You know, I was just like, oh, bing, 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 and not really. Oh. Suppose that z-scores come from a standard normal distribution. Use the normal applet to answer this question. What proportion of the z-score will be between -1 and 1?
So it'd be 0.683. That's what I have. What did everybody else get on that? Is that what everybody else got?
Well-
I didn't do it, so I don't know.
Yeah, I just had a question now, but it would have, obviously with the 68, 95, 90 whatever rule,
So
you're gonna have to be close to 68.
The Z-score is going to be actually a little than that, what we used to call the empirical rule, the 68, 95, 99.7. So the answers will choose the applet. You're going to get an answer that's just different in some cases. So just in the future, don't use that 68, 95, 99.7 rule unless they specifically ask you to use it. That's a general rule. It's awesome. It works pretty well, but it is not as accurate as using a Z-score.
Got it.
So they're trying to show, though, it's pretty close. So you need to open that applet, and you need to shade that center portion and put a Z-score in of 1, and so that you've got that center section shaded with the Z-scores -1 and 1.
And it comes to 0.6827.
yep.
So round it
Okay.
to 0.683.
683. Okay.
As you explain it, I see it on the applet. Yes.
Okay. Cool.
683.
Awesome.
0.683. Okay.
And then the next one will be as if we enter -2 in the Z-score, or 2 and -2. So it'd be between -2 and 2 would give us the area, right?
Right.
So
That's,
I got 0.955.
yeah, 9545. So 955.
I see that. Do you see that, Joan?
Yep. .955. Right? 0.955. Is that what we're
Yep.
putting in there? Okay.
That's what I got.
Now you do the same thing with the 3, make it a 3.
Yep.
Ah. What did you get on that one?
So I got 0.997.
Okay. Me too.
No, I don't.
Okay, we'll stop and talk about this one then.
What did you get?
1. I have a 1.
Okay. So
That means your 2 tails are
Your-
shaded as well. You want just that
yeah.
center thing.
So the thing left to the -3
yep.
and the
Got
thing
it.
right to the
Okay.
4 is shaded.
0.997.
Yep.
Okay. Wow, so you really have to. Because I didn't really even notice that, so I guess I'll have to pay attention to that.
Yeah, well, when you get out there 3 standard deviations, you get such small probabilities in the tails, it's really hard to tell that they've even been shaded. But if you've got an area of 1, that means everything's shaded.
Oh,
Of course.
that
Of
makes
course.
sense now. Certainly, let me put that in my notes.
So look carefully at your answers to the last 3 questions. What do you observe? Yeah, it would be the value. The values match the 68, 95, 99 rule.
Right.
Yeah.
Yeah, which I don't love that answer because they don't perfectly match.
Right.
But the other 2 are totally wrong. So
Yeah.
So by process of elimination.
yeah, they almost match. They're very close. They're, but they aren't an exact match. So I don't love that question.
Okay.
Sister Lemon, are we going to be calling this the empirical rule or the 68, 95, 99.7 rule in this class?
They say, yeah, they call it the. I think empirical rule might be old school. So it's you know, I think it's old school. It's kind of like, well, maybe I'm so old that none of you like. We didn't used to call it categorical information. Do you remember that? We used to call it we'd call it qualified. Remember, we used to call it was it quantitative or qualifying? And it was qualitative. Remember that? It was qualitative. Now they don't even use the word qualitative. They call it empirical. So they used to call it the empirical rule. Now I guess they just call it the 68, 95, 9.7 rule. So
okay, got it.
Seems more confusing. You know, like,
so they just have changed some words. You know. All right, so 13 is the one I think, Joan, you ought to consider just, we'll draw as we go kind of thing. There's a lot of information, and the bottom line is what you need to know you need to dig out is what's the mean, what's the standard deviation. That's what you need to dig out. That's what's most important.
okay. So, sorry.
So
The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein will be normally distributed in the population. Protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram of body weight. Population mean protein requirement for adults is 0.65. And the population standard deviation is 0.7.
I'm just going to share my screen. So this is me. So Joan, this is totally.
Get off of the quiz and look at.
Well, just an idea. So this is what I do. So this is me. I'm like, okay, it told me it was normal. I'm drawing normal. Then I go in here and I put the information in. So I'm like, let's see if I can get this to draw for me. All right, let's see if it'll draw. Of course, it doesn't want to draw for me. There we go. So I put my mean to 0.65 here. And then this is just how I did it. Then I'll just put a little dotted line here. Note that this distance from the mean to what is, I'm told, the standard deviation is equal to 0.07. So I took all that information and I've just drawn that. Okay. It doesn't matter. 0.65. You don't need to know the unit of measure. I mean, it's nice and confusing. What is it? Grams of protein per kilogram per day. I mean, it's like, oh yeah. So, but I've drawn in information I need. So then go to question 13. What does it tell you to do?
what proportion of a population have a protein requirement that is less than 0.60?
Okay, so without being perfect, I know that 0.60 is obviously somewhere. So I have an X value of 0.60. And and it says the proportion that is less than. So I know I'm looking for all that area. So that's my drawing. Find that area and not have to use calculus. What I need to do is I need to standardize that score. So right below here, I'm just going to say, well, instead of X, I need to get associated with it. So 0.6 minus 0.65, that's the distance from the mean. A standardized score has units of measure standard deviation, so I have to divide by the value of standard deviations.
Can I ask one question? Or
yeah.
So looking at your chart, would it not be the 0.6? Wouldn't it be on the other side of that line?
0.6 is less than 0.65, so it's got to be to the left.
Oh, sorry, the mean. Sorry, forgot. I was looking at the mean. Sorry, you're right. Okay. Yep, makes perfect sense.
And then what I have is, and I note that my z-score is negative, which totally should make sense because negative in math is directional. So that negative means left. So that negative is stating that 0.6 is to the left of the mean, and the 0.714 says. So standardized, the value of 0.6 is left of the mean 0.714 standard deviations. So again, this is just one way to do it. This is how my brain works, and it does not have to be how your brain works, but just as an option. Now I'm like, okay, I've got the standardized score. I've got the area already shaded, right? Is go into that normal probability applet. So now open your normal probability applet. And just kind of follow the drawing. So it's obviously the z-score is to the left. So I'm gonna put this value to the left of the mean in the box that's to the left of the mean, just that left area. I've drawn it out, and I'm just kind of copying that onto that normal probability applet, and then you should be able, once you put in that negative 0.714 in that left box, and you've shaded that far left, now look up at the area, and it should tell you the area.
0.5248? 525?
5.238.
Yeah, it should be 0.238. So do you have more than one area shaded?
Doesn't look like it.
Do you have negative 0.714 in that Z box?
Yep, negative 0.714.
Can you share your screen maybe so we can look?
Yeah. Or mine. Hold on. Okay.
Ah,
Yes, you don't want that. You don't want the middle section. Look at this you drew.
Okay. Well, I didn't shade it though. It just when I put the number in, that's what happened. Something's weird going on. Okay.
Click that center, and you need to click just the left.
Okay, so
There you go.
Oh, okay.
The center was clicked because we've done those earlier problems. So you're going to have to unclick and click the areas you want shaded.
okay. So it's 0237, 238.
238.
Yeah, 238.2. Yeah. And one of the things you can always help yourself if the value is below the mean and you're looking at the area to the left, it's got to be below 50% because remember the mean is the 50th percentile.
Okay.
All right. We can say the 0 percentiles down here, 50 percentile, and way up here is your 100 percentile.
Nikki, how you doing on this particular problem?
I'm doing good. I'm just just figuring out the shading and stuff. So
Yeah.
I understand that now. Yeah.
Okay.
Thank you.
Because I was kind of confused too, and I didn't hear you.
So what it's telling us is, this proportion is 0.238. So what it's telling us is if you have a protein level of 0.60, less than that proportion of people that have a protein level of 0.60 or less is about 23.8%. So Another way to say it is 23.8% of the people have a protein level of 0.6 or less.
Okay.
Got it.
Okay.
Number 14. So what proportion of the population have a protein requirement that is more than 0.60? So would that just be filling in the other side of the...
Yeah, so unclick the left side and you want to click all of this.
So the middle and the right side.
You got to get all of that filled in.
So 0.7.
Or you can look at it. Yeah, or you can look at it as the complement rule. This whole thing has to be 1. You know this is 0.238, so you know this is going to be 1 minus 0.238.
Okay.
Another way to look at it.
Sorry, say that again.
The complement rule.
Hmm.
So you know that this whole area is 1. Under the bell curve is 1. And if
Correct,
you know
okay.
this part in the green is 0.238, then you know this yellow part will have to be 1 minus 0.238. In order that pieces together, you'd get the 1. But you don't have to think about the complement rule. You can just merely shade the normal probability applet.
Oh. So then it's 0.76 too?
Yeah,
Yep.
that makes sense.
On there. Good.
That was for 15, correct? The 0.762?
14.
14.
Oh, that was 14. Oh, yes.
I think that's the same answer that I got for 15.
Okay, that's what I was saying. I just did 15. So I was curious because it had the same one.
Okay, so one
What
of the things
proportion
I
of the
just wanna-
population have a protein requirement that is less than 70?
So one of the things I want you to notice is what was the z-score associated with 0.70?
Yeah, so this one comes out the positive of the same z-score, right?
Yes, and so why do you think that is, or can you see why that is?
Well, it's great. It's more than the
What?
mean, so it's greater than the mean.
Yeah, so that creates the positive. You notice about relationship between 0.6 and 0.65 versus 0.65 and 0.7. They are equal distance from the mean, but in opposite directions.
Okay, that's interesting. Okay, yeah.
Does that make sense?
Yeah, that makes sense.
So that at the same z-score because 0.6 relative distance away from the mean as 0.7. It's just that one's to the left. That's why it picked up the negative z-score, and the other one's to the right, and that's why it picks up the positive z-score.
Okay.
Joan, you okay?
I hate math. I hate it.
I'm actually a little bit
Just
lost in the darkness on 15 too, even though it sounds very obvious.
Okay. No, it doesn't need to be obvious at all. So let's just go through it. So same thing, you just start here. We got the same mean we can draw in and the same standard deviation, but now you just need, it doesn't have to be perfect. Just draw in where 0.7 would be. So we've got the, your mean is, so this time we're over here. oops, I can't draw straight, and X is equal to,
You need to share your screen.
that would be helpful, huh? Okay, so see, I just put 0.7 up there. Does that make sense?
Mm-hmm.
I've got the mean is 0.65. This standard deviation, I'll draw it on this side this time, is 0.07. And then it just asks me for area, right? All the area less than 0.7. Does that make sense?
Mm-hmm.
And so I need to figure out what that area is. Well, the only way I can do it, relatively cleanly is to use that normal probability app, but I can't put in raw data. I have to do standardized data to standardize this 0.7 value.
Please don't do that when I'm in the middle of class.
That makes sense?
Yeah. Yeah, no, I understand it. I get it.
Okay, and so I was just pointing out that because 0.7 is the same distance from the mean as 0.6 was,
It's just going in a different direction.
right? Exactly. That's why I got the same z-score of 0.714, but this one's positive because it's to the right of the mean.
Oh, the last one was negative?
Uh-huh. Yeah.
Oh,
Because it lived to the left of the mean.
okay. That's making a little bit more sense.
So for question 13, then, do we put in a negative? Or the area is never negative or
No,
positive?
not the, you put in a negative or into the applet. Remember?
Okay, but, right.
Okay.
But the 0.238 doesn't have to be a negative or a positive.
No,
area.
it's not. It's a proportion. It's the actual area
Right.
under the curve. Now that I've got it drawn out, it should be just naturally you're going to go values to the right of the mean. So you're going to find the box, and you're going to put in that value. And then you're going to click to shade everything to the left. So for that applet, that means you have to click the center and that left piece.
Okay,
And then what do you have and then it should tell you the area.
with the 0.714.
You put that in, that's your z-score.
Right.
You put that in there.
Yep.
Okay, and you click both those areas,
The middle.
completely shaded. Okay, and then now look up at the area and it should tell you what the proportion is.
And I have 0.7624.
You did perfect. That's perfect.
Okay.
Just round it to 3 decimals, though.
Yeah, 762.
Yeah, perfect. That was perfect.
And that's for question 15.
14 and 15.
Right. All right. Oof. 16. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7.
So here's oops.
So I'm thinking that on this one, all we have to do is click on the blue region to the left and only have the big column in the middle.
Yeah, this is all you're looking for is that middle section.
It'd be the 0.525.
Hey,
Mhm.
that's what I got. Very good.
Yeah, the nice thing is, and they usually are nice at this level if they give you value that's equal distance from the mean as the upper bound value, it'll have the same z-score, but one's negative, one's positive, and then therefore you can just put in that value into the applet and shade just the middle. Right? If they didn't have the same z-score, it wouldn't be as clean and easy.
Right.
So if they didn't have it, then you would subtract the area, correct?
Yeah, you'd have to find all the area to the left on the upper bound and all the area to the left of the lower bound, and then subtract those two values.
Okay.
I mean, because we had already found this one was 0.762 and this one was 0.238. So you could subtract those two and you'd still get. Does that make sense?
Okay. Yeah.
$17. Find the 35th percentile for the protein requirements for adults. Round your answer to 3 decimal places.
Okay, so this one we work back the opposite direction. So here's, especially if you hate math, here's something to writing in your notes. So we know z-score is equal to x minus the mean over the standard deviation. So we should also note that z times the standard deviation plus the mean is equal to x. Nice formula to have when we want to solve for the value. So if you hate math, that's kind of a good formula to keep handy for these percentile ranking questions.
Okay, so then z times standard deviation plus the
So what-
mean plus x.
So what we're looking for in this question is what's that x value? We know this area 5% or the 35th percentile. So to the left, that's got to equal 35%. So what's the protein level associated with being in the 35th percentile? So that's what it's asking us.
Okay.
So on this one, you are going to do the opposite. Instead of end up starting the applet. So the very first thing you need to do is you need to go to the applet. You need to shade just left region right there. I've drawn it. And then up in this area box, you're going to put in 0.35. And then I want you to tell me what is the z-score associated with having 35% of the area to the left.
0.385.
That's all I
It
got.
needs to be a negative.
0.385.
So negative 0.385. Yeah, does everybody understand that?
Yep.
Yeah.
Now it's simply just chug some math here, right here. I know that the z-score is equivalent to negative 0.385. I know the standard deviation is 0.07. And I know the mean is now solve for x and tell me what the protein level is for the 35th percentile.
So would it be 0.623?
Makes sense to me.
Anybody
It's
else?
valuable.
Yeah, I got that as well. 0.623, right?
Yeah.
Okay, so a protein level of 0.623 is equivalent to being in the 35th percentile.
Okay, I don't have that.
Let's
Talk
we can
about
walk
it.
through it. So what did you get?
I don't even know. I erased it already.
Okay.
Yeah, I agree. Let's go over 17 because I'm hazy on that as well.
So you can always interrupt me, Sister Lemon, if you want to explain it
No, I
better
think
than I can.
Yeah, and I don't
I
even,
doubt it.
and that's just it. Like right now, I don't even know where to start.
So
So,
then, in the applet, did you in the area, in
Yep.
the top part, did you put 0.3500?
yep,
Yes.
Okay, and then what was shaded?
the left side. So I have
Okay.
0.385 as the z-score.
Okay.
Negative.
So you have your
It's
Z
negative.
score. So what is the standard deviation? So from the above, right, we know that the standard deviation was 0.07, right?
Right.
And then the mean is 0.65. So it would be
Right.
the z-score times the standard deviation plus the mean.
That was perfect explanation.
5 times 0.07 plus 0.65 equals. Remember?
0.623.
Okay. Yep. I think I didn't do the negative 0.385 when I calculated it before.
Yeah, you want to make sure that if you are dealing with a percentile that is less than 50%, it's going to be a negative z-score. Because remember, the mean is the 50th percentile. So if you're dealing with you got to grab that negative z-score if it's below the 50th percentile.
And if we use the formula that we're taught in the textbook, Z equals X.
Mhm.
Well, so, and where do we get the X?
That's what we're solving for in this case. So that's why if you look right here, that's why I kind of just manipulated the formula so that it was solved for X.
Okay.
Because that's what we're looking for. The X is kind of the raw data point, and that's what it was asking us. What's the level associated with the 35th percentile? So it's asking us to find X.
Okay.
So if you look at that, Ed, we had the z-score, right? Negative 0.385.
Yeah.
And we had the standard deviation. So we times that by the standard deviation, which is 0.07.
And then
And
we
then
add the mean.
Add the mean, and then that gives you X.
Okay, I got it. I was just thrown off because I was using the formula from the textbook. I think the new formula is definitely going to be easier.
And so
Yeah,
this
it's
is
easier
the formula we want to use when we're looking for the percentile.
Yeah.
Correct. When you're looking for the raw data given, so you're given the percentile. Yeah, it's just an algebraic manipulation of this one, but it's just a lot nicer, just kind of manipulated for you, and then you can just kind of plug in the information.
Okay, I think I've got that.
Ed, do you want to take us through 18? So maybe if there's any unanswered questions or uncertainty, we can walk through it real quick.
Okay, find the 80th percentile for the protein requirements for adults. So the 80th percentile would be on the applet. We'll put in 0.80.
And then make sure you got the correct area shaded.
Oh, the area shaded. We find that our z-score is negative 0.842 times the standard deviation of 0.07.
Hold on. You don't
Am I-
want negative. The 80th percentile is above the mean, so it's got to have a positive z-score.
Oh, I see on the applet. Yeah, okay.
So you've got the right 0.842, but you need the
Okay.
positive. You don't want the negative. You want that positive.
Okay. Plus the standard deviation of 0.07. No, times. Okay. Z equals 0.842 times the standard deviation of 0.07 plus the mean of 0.65. So 842 times 0.07 plus the mean of 0.65. 0.65 is 0.708 or 709.
Yep.
Yeah.
Okay.
Perfect.
Okay.
That was perfect. And that was perfect. Nice job.
Thank you. I think I'll forget this as soon as we.
Yeah. And just an FYI,
Yeah.
those last 5 questions, question 13 to 18, favorites on the exam. Like you'll see one
They're
of
what?
each one of those.
Okay.
The department loves those. I'll guarantee you'll see one of each one of those
Oh,
the first exam. So if it's something that you like, it's a little bit of a struggle, you get 1 page of notes. And so I suggest you actually write an example down on your notes. Like give yourself a little question and literally write the problem from beginning to end, with
Okay.
notes. Something like it on the exam, you're like, oh my gosh, this always is a struggle for me. Then you can go in your notes and read an example and follow that example.
right.
Basically allow yourself to kind of then process that in the numbers for the exam.
Right.
And you'll see they'll be on the homework quiz. We'll be using z-scores a lot. We'll be looking at probability under the bell curve a lot.
Okay.
So you're going to get lots of practice at it, but get comfortable with what these questions 13 through 18.
Got it. Are we ready to submit?
Yeah.
Should we review any of them before we submit? You okay, Nikki? You sounded like you were. And Joan?
Yeah. I think I got it all.
Okay. I kind of have that question mark in my head as well, but I think I've got it.
It's new and different, but it'll settle in as you practice it, I think.
That professor, whoever that was that does the examples, the tutorials, he does a really good job.
Yeah,
Yeah.
brother Cromar, he does a really nice job.
Yeah. That helped me out a lot.
Yeah, I agree. I tried to read tough, for this course, but if you can have someone kind of walk through some examples with you, it makes a big difference.
Right.
Yeah, this meeting helped a ton. I was really lost until going through all the problems. It now makes sense.
All right. 100%.
Hey, can I ask a question, Sister Lemon? On the
Absolutely.
on the homework, we had to use an Excel spreadsheet to make a QQ plot and a histogram. And my QQ plot and histogram charts don't look anything, well, I guess I don't know how to make the chart in Excel. And when I input the data on the spreadsheet, the data doesn't automatically populate inside of inside of a chart that looks like the chart that's on the sample spreadsheet. I wonder if I can show you.
Okay, you cut out a little bit, but so when you put in your data, your histogram didn't look like the histogram on the answer key. Is that what you're saying?
Yeah.
There's your histogram. Well, I need to look at the exact one, but a lot of what they have on their answer sheet, they've built their histogram on a program called SPSS, which is it's just programmed a lot better to make statistical graphs, and Excel is not. Like Excel, you can't change the bandwidth. It's really limited. So it rarely is going to ever, if they've done theirs on SPSS, your Excel one will rarely look exactly the same. The QQ plot should look, histograms are rarely the same. Excel creates its bin widths and doesn't allow you to mess with those.
Okay, can I try to share my screen for my Excel?
Yeah, absolutely. Yeah, absolutely.
Does that show up? No?
No.
Share screen.
So if you go share screen and then pick the application.
Oh, there we go.
Gotta somehow.
You can see that now, right? This particular one is the body temperature. And we input.
So how come you have two QQ plots? What's this QQ plot?
Well, this is the sample that's it's linked to the resources, and we download a blank histogram.
I got you.
And QQ sheet. Then we input all this data on the left, and then we sort it in ascending order. And then
so part of the problem, why, because I'm looking, no, this is totally good. You did it all right. The issue, okay, I'm kind of a little getting old and blind, but there you've got a secondary QQ plot. Is that one from the answer key, or where's that one coming from?
Yeah, this QQ plot was on the blank spreadsheet. And this
one, what's the other one?
This one is the one. I'll show you what I did. I went to insert. I think
don't use that one.
Recommended charts.
Yeah, get rid of that QQ plot. Yeah. Programmed by Excel to have certain values, and we don't want that one. We want just the one that's been pre-programmed for Math 221, done all the formula the way they want it. So don't create your own QQ plot from the Excel options. Just use the QQ plot. Does that make sense?
Yeah, except then I don't know. I don't know where to get a QQ plot from the iLearn, then from the resources.
You go to the quantitative descriptive statistics.
Oh, that's actually what this is.
Yes, that's the one you want, and it's got the QQ. You've got a lot. Yeah, it just has the QQ plot as a sheet. Just use that one. It has to be that one.
Well, this one. Yeah. If I get rid of this,
one.
Let's just say I get rid of that.
That's the one you want to look at.
Okay, but this was exactly what was there before I inputted the data, so it didn't look like it did anything.
It's like it has, well, I can't tell you because you've got a mean of 98, which would make sense for this data. It should be. I can copy and paste it back in.
Sorry about that.
Cute little guy. No, it's awesome. Let me see your body, Tim.
Okay. Okay, can you see now?
Okay.
Lemon?
Okay. So,
this
got it. Got it.
plot, this is the one that comes with the blank spreadsheet. And
Because it's got this data on it.
this is the one that I made. Oops.
Oh yeah, it doesn't have the.
It's exactly the same. So it didn't automatically create a histogram with the new data.
Okay, something. Okay, I'm not sure. So copy and paste that data again. Let me see what happens. Somehow it's glitched because it doesn't look like you have enough. It should automatically create the QQ plot when you import the data.
Well,
Formula. See, I don't see a formula. That's what I'm worried about. It seems like the formula's missing.
Hey, Ed,
But
yes.
I'm wondering, did you just copy and paste that page?
Yeah, well, initially I copy and pasted it.
I think maybe the formula to create the QQ plot did not come over when you created that sheet again.
Okay.
Do you see how this FX and it's blank in there in the FX? I think what happened is you copied the sheet, but it didn't copy the formulas, and that's why you're.
I know exactly what you're saying. So I'm going to have to redo these. I know what you mean. And that's probably what happened because I did copy the information onto a blank spreadsheet so I could add all of these other tabs and stuff. And
so came over is what I think has happened.
Okay, no, that's probably the case. And if it's not, then I'll let you know. But I think that's probably it. I'll spend some time doing this.
Spend chance because you can always re-download the quantitative descriptive statistics and it'll the formulas again.
Right. Do you know, will it allow me the chance to download the quantitative descriptive statistics spreadsheet at every single lesson?
Yeah, you can download it and rename it anytime.
Okay.
Yeah.
Okay. I think I'm on the right path now. Okay. Okay, good. I'm done.
All right. Well, thanks for letting me join you, Joan. Let me know if we need to want to go over a couple more problems because I know that would really make you so excited. But I'm happy to do it if you want to,
I
just
appreciate
practice
it.
some more problems.
I appreciate it. And between you and Jenny, I'll get through it.
That's right. Jenilyn hated math too.
Oh my gosh, it's just my existence.
If you just want to, walk through, process through, talk about it, whatever.
Okay, I appreciate it.
Same with anybody. If you have questions, if you just want to do a couple practice problems, shoot me an email or a text and we can work out meeting online.
Perfect. Thank you so much.
Thank you.
All right. Thank you.
All right.
Anything else? Listen, I'm traveling next week for work. I will be in South Carolina. I don't have the agenda yet. I won't get it till I check into the meeting on Monday. So can somebody else take to send out the link for the meeting for Tuesday?
Oh yeah, I can do that.
Okay, because I don't want to be responsible for that because I'm hoping to be able to join, but
and I still haven't learned how to do that.
On the announcements, go back to the announcements to
I am, yes.
And it'll walk you through. It's not too bad. Joan, if you can't meet with your group, because just let me know and I can be your group.
Okay, thank you.
All right. All right,
Yeah,
thanks
I travel
everybody.
home on Thursday, so I should be okay for Thursday's meeting. I don't know what the agenda looks like yet for Tuesday. So,
All right, just let me know. Get some sleep sometime soon.
okay.
Thank you. Good try to.
Yeah, good
Yeah.
luck. Good luck with that newborn and
I
toddler.
know, right? Yeah, well, in 6 months maybe, huh?
Yeah.
Okay, let me know if you guys need help.
Well, thank you.
All right, thank you.
Bye-bye.
Thank you.
Thanks, everybody. Have a good
Bye.
Thank you.
Bye-bye.